This video is a continuation of gradients, 5, section C.2, on parallel and perpendicular gradients. I've drawn two sets of lines here. The first two are parallel to each other. We know that partly because they look parallel, but even more specifically because I've drawn the little arrows on them. And whenever you see two matching arrow sets like this, then you know the lines they're describing are parallel to each other. I think it makes sense. You'll understand if I say the gradients of two parallel lines has to be exactly the same, because the steepness of this line is going to be the same as the steepness of this line. If I take parallel lines and put them on top of each other, they're going to follow the exact same path. So we can write, if two lines are parallel, their gradients are equal. Okay, that's writing it in words. If we put that into math symbols, then I might call this line 1 and this is line 2. And then I can say that the gradient of line 1 is equal to the gradient of line 2, if the lines are parallel. This line, if I pick points carefully and say that's approximately on that intersection, and well, this is a little off, but it's approximately on this intersection, it's not going to be quite the exact slope, it'll be close to it. I can count a change in the vertical direction, 1, 2, 3, 4, and a change in the horizontal direction, 1, 2. So 4 over 2, that means that the gradient of line 1 is approximately equal to 2. So that means if I needed to know the gradient of line 2, I could simply say, well, without even figuring it out, since it's parallel to line 1, it's also going to be equal to approximately 2, assuming they're perfectly parallel, which they may not quite be. Okay, but that's the theory behind it there. Okay, the trickier one is if two lines are perpendicular. Perpendicular means they're at right angles to each other. So if I draw this line, then this one is at a 90-degree angle to the first line. So that's what this box means. This box means 90 degrees. And if lines are 90 degrees, then they are perpendicular to each other. Okay, so two important vocabulary words, parallel and perpendicular. If the two lines are perpendicular, they have reciprocal and negative gradients. We're going to look a little closer at what that means. So reciprocal, maybe that's a word you've heard before, I hope so. And negative is certainly one you should remember. Gradients. Let's start with negative. So if I know that this gradient, let's say that's 1, 2, 3 over 1.5, little trick there, but let's say that's gradient of, well, 3 over 2, let's make it that. So line 1, that's this one here, is equal to 3 over 2. Then line 2 has to be negative to that. So if line 1 is going positive, then if this line is at a 90-degree angle, it's going to be going in the other direction. Remember, I can tell a gradient is negative if I go from left to right, if I go this way, and it's going down. So let's walk this line. Let's go from left to right, and then I'm going down. So that's negative. This one is positive. So they've got opposite gradients. If line 1 is positive gradient, then line 2 is going to be negative. It works the other way around as well. If I had started with this line as line 1 and it was negative, then the gradient of the perpendicular line will be positive. So you always flip the sign no matter what it is. So it's the negative of the gradient. And a negative of a negative is a positive. So if it's negative, it becomes positive. If it's positive, the perpendicular gradient is negative. This reciprocal part, maybe you remember what a reciprocal is. If I take the reciprocal of 3 over 4, then to find the reciprocal, I flip numerator and denominator, so the reciprocal of 3 over 4 is 4 over 3. Those are reciprocals. If you multiply reciprocals by each other, they should give you 1. This is 12 over 12, so that's equal to 1. So the reciprocal gradient means that I flip the top and bottom. So I know it's negative, and then I make it 2 over 3 by flipping the numerator to the denominator and the denominator to the numerator. If you think about graphically what that means, maybe it makes sense if you think the y value here, the vertical change, is now going to be a horizontal change. And what was a horizontal change is now going to be a vertical change. So that's why those two flip. Okay, one thing we should note is that if you have a gradient that is a whole number, let's say we have a gradient of -4, then the reciprocal negative gradient of a perpendicular line is going to be the opposite sign, so it's going to be positive, and the reciprocal of 4 is 1 over 4. Think of the 4 as 4 over 1, and then it becomes easy to see that this denominator becomes 1 in the reciprocal gradient, and the 4 moves to the bottom. One other thing to note, just like if I take two reciprocals and multiply them together to give us 1, if I take two perpendicular gradients and multiply them together, let's take the 2 we have over here, 3 over 2 times -2 over 3, you always get -1. Because 3 times 2 is 6 and 2 times 3 is 6, so that's 6 over 6, and positive times negative makes negative, so this becomes -1. And that's actually a property of perpendicular gradients, that if you multiply them together, they will give you -1. So you can also test if two lines are perpendicular to each other by multiplying the gradients together. If they're equal to -1, then they're perpendicular. That works here on one like this too. If I take -4 and multiply it by a quarter, right, 4 quarters is a whole, so 4 times 1/4 is going to give us 1, and negative times a positive is negative. So indeed, we get -1 again. Okay, let's try a sample problem, the kind of things that you might be asked to work with. All right, e.g., for example, it's Latin for example. Let's take a line and join 2 points on this line together. So a line joining point A, which is 2, 3, 2, -3, to point B, let's call it A, -1, and say that it's parallel to a gradient of -2. Changed colors on me, sorry about that, of -2. And we're going to use that to find A. See how my point B is missing a coordinate? I've just put A in there as a variable. So I only have the y coordinate, and we're going to find the x coordinate. So key in this problem is that I've been told the lines are parallel. So that means the gradient of two parallel lines is the same. So if the gradient of my parallel line is -2, then the gradient of this line is also going to be -2. So I'm going to set up the gradient formula that we learned in the last section, y2 minus y1 over x2 minus x1. And I'm going to set that up with this information. The gradient is the same, so I can use -2 as my m. That stands for the gradient. And y2, I better label my points so I know which ones to take. Let's call this point 1, so this is x1, y1, and this is x2, y2. And then I can plug in the points. y2 is -1, y1 is -3, so I'm subtracting a -3. Little use of brackets to keep that negative with the 3. Divided by x2 is a, and x1 is 2. So now I have an equation that uses algebra, and I'm going to solve for it. I've got fractions, so the first thing I want to do in order to make the fractions a little bit easier to deal with is to multiply both sides by a minus 2. So I'm going to multiply this side by a minus 2, and I'm going to multiply this side by a minus 2. Got brackets, so I'm going to have to expand. In the next step, I get negative 2 times a minus 2. Imagine that next to each other. Then I have negative 2a, and negative 2 times negative 2 is positive 4. And that's equal to the top here, because this and this cancel. I divide by a minus 2, and then I multiply by a minus 2. That's exact same number, so that's going to cancel. And in the numerator, I'm left with negative 1 minus a negative 3 is negative 1 plus 3. So both of those things have to be equal to 2, adding those two things together. So I have a regular linear equation here with negative 2a plus 4 equals 2. The next step is to subtract 4 from both sides, and subtract 4 from this side, and subtract 4 from this side, and get negative 2a equals 2 minus 4 is negative 2. And then I'm going to divide both sides by negative 2. Always what you do to one side, you always have to do to the other side. Regular algebra rules, and I get a is equal to 1. Okay, so my point B is then 1, negative 1. Question asks to find a, so we're done. Okay, I'm going to do one more problem with a perpendicular line. In this line, we're going to join 2 points. Let's call them D and C this time. D is from negative 1 to negative 3. And we're going to join it to C, which is 1t. And we're told it's perpendicular to a line with gradient 2. And we have to find t. We're going to use the same formula again. M equals y2 minus y1 over x2 minus x1. Point 1, point 2, so my my y2 is over here. This is x2, that's y2. You can label it again if you want to. I'm not going to save a little bit of time. So I start with t, that's my y2, minus y1 is negative 3. And divide that by 1 minus a negative 1. And I forgot one thing. I also have my m. This is the crucial thing because now I have a perpendicular line. So if the gradient is 2 of the perpendicular line, then the gradient of my line is going to be a reciprocal gradient. So the gradient of the line I'm looking for, I have to change the sign, so it's going to be negative. And I have to flip it. So if this is 2 over 1, then my perpendicular gradient will be negative 1/2. So this is equal then to negative 1/2. So I'm going to multiply both sides by 2. And I'm going to multiply both sides, oh, what's that? That's also 2. So that makes it quite easy. Let me simplify this first. Let's do t plus 3. Remember, subtracting a negative makes a positive. And 1 minus a negative 1 is 2. So that's equal to negative 1/2. Again, I have fractions. Those are not so easy to solve with. So I start by multiplying both sides by 2. If I do that, then both of those denominators cancel. And my next line looks a little bit easier. That cancels with that, so I just have t plus 3. And this 2 cancels with that 2. So on this side I just have negative 1. And then I subtract 3 from both sides. And then I have my final answer. T equals negative 4. That's what I was asked to find, so I can circle that and say t is equal to negative 4. Okay, that's it for this video. You're ready to do exercise 5C.2.